Recording in progress.
Great. Okay, so B65 is asking you to Davis, thanks. B65 is asking you to brainstorm a situation that fits data. I'm not going to ask on the test, so don't worry about that. I think what you should know is how to make the equation from the table or from the graph. Fortunately, part B already gives you an equation, so don't worry about it. But what you should probably realize from part B is that the initial value is 180. And it's growing. What would be the percentage growth for B? What percent growth do we see here there? If it's 1.22, goes Rock? 22%, perfect, thank you. And if you were to come up with a situation, you could say, hey, there's 180 people in my class, and the rate that people are getting sick per day is 22%, which sometimes happens in the flu season, right? Seems like a lot of people get sick very quickly at the school, or at any school, for that matter. For A, that's 16,000, and then after 1 year, looks like you're down to 14,000. If you were to make an equation, it could look like this, right? But how would I solve for B? What would I do? What other things? Davis, go ahead.
Plug one fraction.
Yeah, just plug another point. Exactly, totally, right. And then solve for B. Because in this case, you get B to the 1 power, which is just linear. And I think that is... If anyone did solve, you could let me know. I'll just do it right now. I think it's 0.875. Yeah, 0.875. So what would be the decay rate? It decays at what percentage? What would you say the decay rate would be? Decays at, if it's 0.875, that means that 87.5% remains. So how much was lost? How much did we lose per year? What's the percent drop per year? If you're multiplied by 0.875, remember y equals a times b to the x. So it's a times 1 minus r raised to the x power when it's decay. 1 plus r if it's growth, 1 minus r if it's decay. What would r have to be in this case to make it 0.875? Thank you, Jack. So 0.125. So 12.5% would be the decay rate. If you were to think of a scenario like a car, if you buy a car for 16,000, usually every year it drops about 12.5%. So you could say that. Lastly, for part C, it looks like that's probably population, maybe the United States. I think the US population was about 225 billion in 1980, I don't know. And looked at the population growing by about 2%. So if I were to make an equation for part C, I could say y equals 226 times 1.02 raised to the x power, where y is in terms of millions. And starting from 1980, you could say that. So, and I think it does look like US population. So, okay. Anyway, let's move on to 6.6. A virus has invaded Letitia's favorite mountain fishing lake. Currently, there are 1,800 trout in the lake. Fish and Game Department has determined the rate of fish deaths will be 1/3 of the population if left untreated. Okay, so the rate is 1/3, so it drops by 1/3. So how are you going to make the equation? It'd be y equals what? And be 2/3, right? Because 2/3 remains, right? So you have to be a little careful about that. So really, think of it like this, guys. Y equals. I know you guys were a little stumped about a couple minutes ago. It really comes down to this for word problems. Really, that's it, right? Add r plus growth because you're growing. Subtract r plus decaying. So that should be intuitive. And then the base would obviously change. Would change according to that. So, okay. So that's pretty easy. And then let's look at part B. Will we ever get to 0? Will we ever have 0 trout? Well, in real life we will, but according to this equation, will we? No, right. No, according to the equation. Because the equation cannot reach 0, right? Because it gets close to 0. So no according to the equation. But in real life, sure, it could happen. So okay. Let's talk about 6.7. Oh, Sophia, go ahead. Mm-hmm. Well, because the question is asking theoretically, that's why. Yeah. If I were to ask that question, I would ask, like, based on your equation, can that happen? And of course, the answer is no. Okay, this one here, let's make an equation again. Should be real easy. y equals 7,000 times b to the x power. And now you guys know how to solve for b. Plug in 7,700 for y. Plug in 1 for x. Solve for b should be 1.1. Easy peasy, right? And x represents number of years since 2010. Use model to predict the cost of attending public university in the first year. Well, it's obviously 7,700. This is plugging 1. What's the cost in 2000? So how would you do that for part 2 if you're going back in time? Yeah, you got to do a negative exponent. So it'd be 7,000, 1.1 raised to the negative 10 power, which is about, what's that going to be? 7,000 times 1.1 raised to the negative 10 power. That's about 2,700 roughly. It's 2698 if you want to be more precise. 0.81, but you're not going to have a decimal of a person. Does that seem, do you feel confident that I would say so, sure. Because, you know, maybe they didn't have many people 10 years ago, more people are joining the school. I don't see why that would be a problem. So I'd say yeah. And then the cost is A244, how accurate's the model. So if you plug in 2 for x, it's not going to be that close. I mean, it's kind of close, but it's not spot on. Yeah, it's off by 200 people. Sorry, $200. Wow, I can't. I'm not talking about people, talking about money. Sorry, we're talking about money. I thought we were talking about population. My bad. Yeah, the cost could have been really cheap 10 years ago. Now we got inflation, right? 8470. So how accurate's the model? I mean, kind of. I'd say it's kind of accurate. What actually happened? I don't know. Maybe they just felt like charging more. No idea. All right. Definitely gonna ask you guys a graph for sure. 100% gonna ask you guys a graph. Now here's, and also gonna ask for domain range. Now, first off, domain range is always gonna be this. Seriously, if you need to memorize it, that's fine. I hope you don't have to memorize that, you understand. But every single time, your domain is gonna be this. A range is gonna be this. For any of these 3 graphs. Now, we are going to shift graphs around in the next unit. We're going to talk about something called transformations. We're not there yet. But for the basic exponential functions, which is what we're doing in this unit, always, 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 all real numbers for domain, range is going to be y greater than 0. If you write all real numbers, if you do this, actually, we just had a discussion about this in the after part meeting. Does some people like to write this? You can if you want. Does anyone write ARN, by the way? Yeah. You guys learned from CPM, didn't you? Yeah, we're a little annoyed with that, but it's okay. It's not your fault. I think CPM's sugarcoating a little bit. All real numbers, I'll accept that too. That's fine. Ultimately, you're going to want to start getting used to this down the road, but it's okay. If you wrote all real numbers explicitly, that's cool too. So I'll accept any of those, just so you know. Y greater than 0, that works. Now the graph itself. Here's what you do. Let's make a little table. Okay. Here's what I'd recommend when you do a table. Usually 3 points are sufficient. I recommend you do these 3. The reason why I recommend these 3 is that you kind of see the whole picture. 0's in the middle, 1's on the right side, -1's on the left side. That's what I would do. So if you plug in -1, you should get 5/3. Yeah. It says without making tables. I don't care. I want you to do a table. So okay, thanks. All right. 15. This one you got to flip the 1/2. It becomes 20. That becomes 10, and that becomes 5. That becomes 1/50th. I'm not gonna do something that crazy with you guys. That's crazy. That's 1/10, and that's 1/2. So when you do the graph, it should be, and by the way, I'll give you guys very clear tick marks. So I'm just doing kind of rough sketch today. That's like 15, obviously. That's like 5. That's -1, 1. So it looks like that. Here, -1 is 20. Way high. 0 is 10. 1 is 5. So it looks like that. And this is also growth, but it's really tiny. I mean, I'm not going to label it because those fractions are really hard to do. I'm not going to do anything like C. That's a little crazy. So anyway, here we go with that one. For 69, and that's the last one. Then I'm going to give you guys a practice. And the practice test, there's some problems that are kind of wonky. I'm going to cross them off, tell you which ones to kind of ignore. But it's 43 questions. I have the answer key also in Schoology. So this is all in Schoology, but I have the hard copies of the practice test. So we'll go over that in just a little bit. Here, you're asked to decide which representation you will generate from the situation description based on what your team needs to work on. Let's just answer the questions. That's just kind of crazy what they're saying. How big will the sample be 1 year from now? So it's y equals what? What am I going to write here? Y equals what, guys, for part A, 69? 100, and what comes after that? 1 minus 0.06, good, or 0.94, and raised to the 1 power. Yep, that's all you got to do. And if I work that out, it should be 94, I believe. 94 grams. Okay. Oh, 1 year from now. Oh, I messed up. Yes, that was 1 week. Oh boy. But how many weeks in a year? Oh, I messed that one up. Yeah, good catch. Good catch. Just ask me, I'll tell you. Okay, I'll tell you. 4 grams. So roughly 4 grams. Okay, next up. Okay, how would I set this up, guys? How would I set part B? Y equals what? Hold on. Yes. Yes. Good, 1.3. To the fifth. Perfect. Thank you so much. Very easy, right? Yep, I get 167. Okay, cool. Let's look at part C. So her money's decreased by 11% each week. After 1 week, she's down to 142.4. How much does she start with? So here's the equation, y equals ABX, right? What am I going to plug in here, guys? What am I going to plug in? How would I do this? Actually, I'll do C over here because I need more space. 0.89. Well, hold on a sec. Do I know A, guys? I don't know A, right? Well, what am I going to put in here? 1 minus or plus? 0.11, okay. And then what am I going to plug in for X and Y? 1 for X, and what for Y? 142.4. You gotta do 142.4 because that's an output when X is 1. When input's 1, the output's 142.4, and they solve for it. So you just kind of reverse engineering this, right? And then solve for A. If you do it quickly, you should get 160 for A. Sophia, go ahead.
For A, I put 4 into the parentheses.
Yeah, sure.
I still got 4.005 grams.
I put 4 grams. I just round to the whole number.
I do that.
Yeah, totally. Yep. Okay, lastly, Larry loves music. He bought an MP3 files. This is old school files for music. $25 is credit card, but the money grows monthly. So how much does he own the credit card if he doesn't make any payments? That's not smart, but anyway. Let's look here. So y equals A times B to the X. So always kind of start with that. What's the initial value of the money he owes? 285, perfect. Now, this is the part that's tricky. Instead of 1 plus R, you have to do R over N. And instead of X, you have to do NT. That's just a slight adjustment you have to make. It's not hard. What's the rate going to be, guys? And how many times per month? Sorry, per year? 12 times. And it's doing this for 1 year, so you do 12 times 1 as the exponent. And that'll tell you how much money is being compounded. Yep, and you get about $340.75. So that's gonna be the balance on his credit card afterwards. Okay, we're cool. We're good. All right. Okay, let me go ahead and stop the recording.